Okay, doing the easier version, valid anagram, because I was struggling with the medium one. Give myself 15 minutes. Let's see if we can do this. So given two strings, s and t, return true if t is an anagram of s and false otherwise. Okay, that was basically like the helper method that I wrote. Yeah. So st true, st false. So many things. What are the length? So by many things I mean like there are many constraints I'm considering right now. I'll kind of note down just so it's clear. So size, dichotomy, order, boundary. What is size of s, t? Only English, like lowercase English letters, uppercase. Like, do you have to consider that? Order, not really relevant. Boundary, kind of like the size, like, can it be empty? How long can it be? Right? Like, do we need to like consider like really high edge cases? And down here it should say, okay, so it can't be completely empty, and it can be quite large. But it doesn't say anything about can they be the same length? Be the same length, right? So if they're not the same length, then we automatically know that's not an anagram. S and T consists of lowercase. Okay, cool. All right, so that's the constraints part. Constraint validation or assumptions ask. You would ask the interviewer in a coding interview these, and then let me just do a brute force. Like, how would I do this on pen and paper? So I would just go through it. I would definitely check if same length. Then I would just go through each letter and check if the other word has it. Go through each letter and check if the other word has it. Now, what's an optimal solution for this? And then, actually, sorry, let me time complexity. So that would be O of n, and space complexity O of 1, I think. Yeah, there's no like storage involved. O of n because you got to go through each of the letters, n being the length of the string. Like, that's what I mean when I say n. Optimal solution, I'm not sure. Can I make it more optimal than this? Like, can I solve this problem without going through every single letter in the like word? I don't know. Maybe I can cut it down by half by like doing a 2-pointer and starting from the top and the back or something. I don't know. I can't think of an optimal. So that just means I'll just go with the brute force for now. If length of s does not equal length of t, we immediately know we can return false. At the end, I know we want to return true. And that's because for I in range 0s, we can assume at this point that s and t have same length, because we've already considered the case if it's not. If si not in t, return false. I think, yeah, that's it. Like, if I go through anagram that and that, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So both of these are 7. So 7 does not equal to 7. That's not true. So we won't run this. We will come here for I in range 0 to s. That's wrong. This should be length of s. Good catch. So si, that's a. Not in t is a, not in t. Well, there can't be duplicates though. Will that be a problem? be a problem. I feel like if there's like an A and a different letter though, it should solve for itself. Like A, and then N, and N, A again, and they'll check the first A, for example. G and G, R and R, A again. Wait, third A. 1, 2, 3. Yeah, first A again, and M. Like I think the duplicates shouldn't matter, but maybe a dictionary is a safer option. Let's see, because I think this would be true. I think this should work. Case 1, case 2, good. Submit. Let's see. Let's see. Let's see. RIP. Okay. So I guess that maybe that edge case was an issue. Let's see. AACC, CCAC. My output is true when it should be false. Okay, so not considering a certain aspect of this question, and that's basically the duplicate. Like this isn't a correct way to actually solve the question. And thinking a dictionary is just a dictionary is going to add space complexity to my brute force solution. Can I do something else? Other one is like, as I get rid of the word, as I check A, then I just get rid of A as I get, things like that, basically. Or maybe like a parallel array, like each, like 1, 1, 1, 1, right? And then kind of adjust the other one as appropriate. Maybe that would be a good one to try. Do I like the parallel approach, dictionary approach? What do I like? I like dictionary approach. It's more easier for me. So, letter to occurrence dictionary. For letter in S. If F is not, if S, hold on, what? If letter, there we go, if letter not in this, then we do letter to occurrence dictionary, letter is equal to 0, and then we just want to increment that, plus is equal to 1. Oh man, I'm hungry. Just drinking a protein shake on the side. Much better. Create a dictionary based on S, and then deduct the values in dictionary based on T. And basically the goal is we're incrementing like 1. So for example, this would be 2 A's, 2 C's. By the end of like whatever loop like I do for letter in T, I want to have an array of just like values of all 0. The occurrence values. So if letter not, we immediately know it's false. Okay. If it is, then we just do if the other case I'd have to consider. If letter is equal to 0, return false. And then we can just subtract. And then check that all occurrence values is 0. Means S and T are anagrams. And then just replace this. So hold on, let me just finish this up before I continue. For letter in this, if this does not equal to 0, return false, otherwise return true. Okay, I'm like 3 minutes in, so I'm just gonna check this, see if there's any syntax errors. Okay, nice, submit, let's see. I probably gotta change the time complexity and everything, but let's see. Nice. So time complexity, need a dictionary to consider duplicate letters. And so worst case would be n. Yeah. Nice. So what I was about to say is that I jumped over to the medium question, group anagrams, and this function I had, I created my own as anagram, and that was incorrect. So good thing to consider in the future. So submit this. I'm gonna push to my GitHub. Nice. And I'll take a screenshot and everything afterwards for my progress checking. All right, that's all for this one.